Well, welcome everyone. My name is Nikki Gordon-Coy, and I'm trying to reduce the glare on my glasses, so sorry if I keep adjusting myself. I am a student at Colorado State University in the Forage Management course. So today I am going to talk to you a little bit about the importance of understanding insects and their effects on forage availability. My background is I am a teacher. I'm a science teacher, but I also have a small farm with my husband and my 3 children. And so I know a little bit about this topic, but there's a lot to learn about it. So I'm going to do a screenshot now over to my PowerPoint presentation. And just bear with me one moment. We will begin our presentation. So again, we're talking about insects' effect on forage availability. And things I'd like to talk to you about today, we're going to look at forage availability and what that means, carrying capacity, roles in the food web, ecological competition, and get into some best managed practices once we go through some invasive insects and what they can do to our forage. This is actually a picture of some of my cows out on one of our paddocks that we have. Forage availability is a measure of available forage in each pasture, and it's basically looking at how much forage are these animals going to be able to eat. And as we've learned, we don't want to be eating more than 50% of what's available. And we're going to be looking at, well, who all's eating this forage and what are our animals competing with. When you're looking at forage availability, I really suggest using a grazing stick. It looks a lot like a meter stick, except, and you might be familiar with them, they're a little bit more three-dimensional. You can slide it underneath your forage and it gives you some tests that you can run to see what your forage availability is before you even go into any type of a pasture or stand. Now let's talk a little bit about carrying capacity. Oh look, oh yes, I thought I put a picture in here. If you look here, this fella is holding this grazing stick. They're super handy. Mine's white. I don't know the difference as far as white versus green, if it helps you determine availability, but it is pretty handy. So carrying capacity. You may have learned about carrying capacity in your high school biology course, but carrying capacity is just like how much living things can live within a specific area. And so if we're talking cattle, of course our cattle are going to be a part of that, but it's not just going to be our cattle. It's also going to be any deer or other herbivores that might be in the area, along with insects. So the carrying capacity of an area is the amount of living things it can support. So it's not just going to be mammals, it's not just going to be birds, it's not just going to be insects or macroinvertebrates, it's going to be everything together. And understanding your carrying capacity for your area, your pasture, your rangeland is going to be very important. It's typically put into a unit looking at, so we have an example here where we have a 1,000-pound cow with a calf who grazed for 1 month. How much could that cow eat? And we're saying, hey, each animal eats approximately 780 pounds per month. So what does that look like as far as what's available? I like this image over here where we have this sort of whole ecosystem represented in this image, and you've got disease and starvation and predation and old age. And if we're talking about wild animals, then we've got this pouring out of hunting. But it doesn't matter how much you pour out. If you're pouring too much in, you're going to have overflow. And if you have overflow, you're going to have animals that are starving or malnutritioned. Is that a word? Malnutrition? Experiencing malnutrition. How is that? And if they're experiencing malnutrition, they're not going to be reproductive. If they're not reproductive, then it's like, what's the point? So we want to make sure that our animals aren't overeating, and we want to make sure that we don't have any pests coming in taking away their forage. So we're going to tie the ecosystem into this forage management concept. So carrying capacity is not only important for livestock, but all biotic factors. If it's living, if it's breathing, it's biotic. So we're talking our plants, we're talking our animals, we're talking our birds, and we're talking our insects. Understanding the parts of the food web is going to be super handy. And I was not sure where all you guys stood with the food web, but I thought, what the heck, I would just kind of run through and just do a little reminder. When you're talking food web, you're talking producers and consumers and decomposers. For the purpose of this discussion, we're going to be using insects as this general term. Really, we're talking about macroinvertebrates in general, because you know what? Spiders are in there, but they're not an insect, but we don't want to forget about them. So it's going to be all the nematodes, all the annelids, all the subphyla of insects. So we're talking crustaceans, because pill bugs and woodlice are part of that. Our six-legged insects, which are your traditional insects. Then you also have millipedes and centipedes and spiders and ticks, you've got the whole thing. They're all a part of that. These organisms are not producers. If they don't have chlorophyll in them, they're not going to be a producer. So all of them are consumers to some extent. Most of them are going to be primary and secondary consumers. We don't really get into tertiary consumers and apex predators when you're talking insects, because something can still always eat an insect. So I generally look at them as primary and secondary consumers or decomposers. So that's the other thing is, it's kind of like Simba and Mufasa out on the prairie, and they're talking about the circle of life, and when the lions die, then they get, decomposed and become the grass. So very important part of our forage management is making sure we have good, healthy decomposers. So producers, of course, capture the sun's energy and they transform it into usable molecules. So that's wonderful. That would be all the forage that we're trying to maintain and increase. That's all the producers. They're really the largest category of biomass. I use this little pyramid a couple times, and not super crazy about the titles over here on the left. Not that there's anything wrong with producers and herbivores. It's just, I'm talking consumers, so it is what it is. But what I wanted you to really notice is this 1,000 kilograms over here, and then you bump up to the next level, it's 100 kilograms. You bump up to the next level, it's 10 kilograms. It's this concept that we are only carrying on 10% of the biomass that we had at the level below us. It's not just biomass, it's also energy. It's this law of tens kind of can be transposed just about on anything. If you're talking, animal biomass, you're talking energy, or you're talking nutrients, what are you talking about? Most of it, you can use this 10% carry through concept. Primary consumers are going to be my cows, but they're also going to be a lot of the insects fall into this category. Here we've got a little grasshopper gnawing away on a leaf. Okay, ingestion style is going to vary from species to species. Is it an insect that, sucks the plant dry, of all of its fluid, or does it, like this grasshopper, chomp down on the green leafy material? What is it that the insect or the animal is actually eating? I know that there's also a big difference between the way my horses eat versus the way my goats eat versus the way my cows eat. So every consumer has its own means and way of eating. Some consumption of leaves, the plant is able to continue and grow and thrive, where other consumption is going to pretty much kill it. And that would be not what we're after. That would pretty much reduce our forage availability down to nothing. Secondary consumers. So secondary consumers, this could be like little toad, little mouse. These are eating things that have already eaten some plants. But in the insect world, we also have lots of secondary consumers. And we might want to spend a little time with this as far as our research when you're looking at your specific area. This topic was a little bit tricky for me because every area's kind of got their own thing going on with insects. And so I just wanted to talk about the generalities and give you some tools as far as what you can look up. It's really going to be very dependent upon where you are and what pests, if we would call them that at this time, what pests are attacking their forage. So we might want to come back to this concept of secondary consumers. Tertiary consumers and apex predators. Largely because of scale, insects are not considered apex predators. Trust me, if a praying mantis was as big as a dog, well then, one, it'd be a very strange world, and two, yes, I think they probably would rank pretty high up there as far as an apex predator. But thankfully, they're not that big, and I could still squish an insect with my boot if I really needed to. Not that I would squish a praying mantis, because of course they're protected. Apex predators are the organisms that are kind of the top dog. Nobody is going to eat them. You know, it's your bobcats, your mountain lions, your coyotes, your owls and hawks, and your humans. But we're not really going to focus on these today, although interesting. Decomposers, though, super important for that forage availability, because they're the ones that, you know, are making sure that the nutrients are getting right back into the soil. Decomposers consume dead materials and therefore return those molecular building blocks back to the ecosystem. Many insects, macroinvertebrates, and bacteria, all those can be decomposers. Although some of these organisms are plant pests, many of them are the antagonists of the plant pests and diseases. So these are kind of our buddies. These guys go after, maybe, especially if it's like the bacteria or something. Or you might have something that's going to attack that pest that's eating your forage, if that's the problem you're having. All right, so what's the relationship? So within every ecosystem, there are multiple types of relationships. Some of these are beneficial, where some of them maybe not so much. There's predation, mutualism, commensalism. Okay, so a lot of these things, well, in predation / parasitism. You know, it's always a fine line in my mind. What's the difference between a parasite and a predator? You know, really, maybe a parasite's just a slow, painful death. I really don't know that would need something I would need to look up there. But in my mind, predation and parasitism are awfully similar, except for like quick death versus slow, painful death. Mutualism, hey, I benefit, you benefit. It's a happy day. Commensalism, I benefit, you don't really notice if I'm there or not. You know, those are, if there's an insect that's having a commensalistic type relationship with a plant where it's nibbling on it, but it's not really killing it, and it's not really preventing it from growing, that's not maybe one you want to focus on. You want to focus on the ones that are getting in there and totally wiping out your plants. When looking at the nature of these relationships of insects and forage, we've got to look at each species individually. I can't emphasize that enough. But as I researched this topic and I looked into it, my goodness, what we deal with in Ohio, here I am in Ohio, what I deal with in Ohio is completely different than what people deal with on the western side of our country, largely because of rain availability. I mean, that's one thing I learned, is like some of these insects really hate a lot of rain. So if you're looking at irrigation as a possibility, you know, well, we'll get into solutions here in a little bit. I'm getting ahead of myself. All right, so here's, now I don't know the legitimacy of this. It's something I thought about. What does the metamorphic stage have, or actually it'd be more like the metamorphic strategy. You know, is it complete metamorphosis or incomplete metamorphosis? And is there any sort of a relationship between the two as far as how much damage it does to your forage? I don't know, something to look up. But what I can tell you is that insects who are going through complete metamorphosis are hanging out for a very long time as a very hungry caterpillar or larva of some sort that would really like to eat your forage. You're looking at an alfalfa caterpillar right here. There it is, chowing down on some, it doesn't really look like alfalfa. Maybe it is, just super close up. Here's the alfalfa butterfly, very pretty. Notice it's hanging out right there on, looks like, I don't know, milkweed maybe, but it's also a pollinator. So you don't want to get rid of every single alfalfa caterpillar because pollinators are good. And so that's where we get back into this concept of some of these things are beneficial to have. Some of them are filling, some not being exclusive to a specific species, some being exclusive to an appropriate number or an appropriate biomass number of them. Maybe 50 is great, whereas 50,000 is not so great. Just like with anything in life, moderation. We want to have all of our species in our forage area, but we want to have them in moderation. You don't want to have too much of anything. If I have too many rabbits, well, then that's going to really affect everything else in that particular food web. Just like if I have too many of these little alfalfa caterpillars. One, they're going to eat my alfalfa, and two, there's just going to be too many of them. You don't want to have too many of anything. So incomplete metamorphosis, just to kind of a recap in case you're not completely comfortable with the different metamorphosis strategies. So complete metamorphosis, we go from looking like, I don't know, something not so glorious and wonderful, but with a big set of jaws, to a lovely butterfly. So completely changes its form. That's complete metamorphosis. And incomplete metamorphosis is going to be something where it just gets larger as it goes through these changes, or these things we call instars. But it starts out looking like a little tiny grasshopper, and it ends up looking like a great big grasshopper. Or it starts out looking like a little tiny hairy chinch bug, and grows up looking like a normal large chinch bug. But they don't really change their form. We'll go into these particular insects here, these chinch bugs, in a little bit, but just food for thought as far as metamorphic stages and dietary needs. Alright, so invasive insects. Here's the thing that I have picked up largely by going through all of this. If it's a native insect, chances are it's not out of check. It's probably the appropriate number of its species. And although it's causing a reduction a little bit of your forage availability, it's probably not totally changing your forage plans. However, if it's an invasive species, and especially if it's an invasive species that none of our native species have figured out that it wants to eat it, then it could very easily get out checked, and it could easily get too plentiful. And then what? Then you're stuck with way too many of some type of insect that you've got to have a best managed practice for. They often don't have these natural predators. Many require additional monitoring because we don't really know how much we're dealing with. Like I know we're monitoring over here for ash borer beetles. Now this ash borer beetle isn't going to attack my forage, but it attacks a member of my ecological community, and so therefore it's a concern to me. It's a long list. Okay, this was I just did a little screenshot. This is linked if you go to my works cited. It's like 101 invasive species that you could look up. I thought this was all going to be Lepidoptera. Lepidoptera is going to be your butterflies and your moths, but it's really not. Now, I didn't go all the way down the list, but just as a small sample, I mean, there's some, and that would make sense because that's caterpillars. But there's a lot of other things that are out there, a lot more beetles and borers and those types of things. All right, so let's talk specific a little bit. I'm not going to get super specific because there's there's just so much you could talk about. I have alfalfa as a large portion of my forage, so we're going to talk about alfalfa. There's the alfalfa weevil, blister beetles, which I've never seen a blister beetle in real life, and I pray I never do, because from what I can read, those things are super nasty. White fringed beetles, army cutworms, grasshoppers, alfalfa caterpillars, which we already looked at, leafhoppers, which, you know what, I didn't give leafhoppers a whole lot of credit. I always just thought, oh, look at the little leafhopper. Well, you know what, if there's a whole lot of leafhoppers and they're all chewing on your alfalfa, that's going to reduce your forage availability. And then aphids, which really like my roses, but also like other things that my cows like. This is a really great guide, and I'm actually going to step out of this PowerPoint real quick and go over to, I'm sorry, it's going to give you weird, there it goes back to me. Hello. We're going to hop over to, let me minimize this. Oops, but I got to do it on a screen share. Sorry. Let me go back to screen share. There we go. And we're going to go over to this guide of insects created by, and I'll look at her name here in a second. Where'd it go? Dr. Carol Sutherland is an entomologist and sure knows a whole lot more about insects than I do. So we're going to take a little page out of her presentation. Not going to spend a lot of time here, but again, I do link to this. Very insightful. First, she talks about how you can collect some samples, because how in the world are you going to know what's out there if you don't sample a little bit? So put on your inner middle school scientist hat and get yourself a butterfly net and go have a little bit of fun. If you've got kids, take the kids out there, grandkids, and, you know, make an afternoon of it. We're going to go sampling. So go sampling and see what in the world is out there if you're noticing that you have some forage availability issues. All right, but here are some of the pictures. This is alfalfa weevil. So we've got eggs. Notice the eggs are in the stem. Then you get a very hungry caterpillar. Great children's book, not great for forage availability. Then they go through just like every other complete metamorphosis. Okay, so it looks like, oh, it's going to be a caterpillar. No, it's a weevil. Well, what's a weevil? It's like a beetle. Whoops. It's like a beetle, but it's got this long snout thing. That's kind of the big difference. And that snout thing can cause damage as well. So they can eat your leaves as this way, and then I'm guessing that snout could probably do some plant matter damage. See, look at that. That's definitely going to reduce your forage availability. That's just the way it is. You know, your cows are going to go, and they're going to say, wait a minute, where'd the leaves go? White fringe beetle, another one I hadn't really heard of, but I'm guessing we could probably throw this guy in the invasive category, seeing he's from South America. And sounds kind of aphid-like. They don't need males. Looks like they're reproducing asexually. And they hitchhike on hay, equipment, trucks, and trailers. So that'd be the other thing. If you're going from field to field, if there is any way that you can spray your vehicle down, that would be a great idea. I know when my vet comes over, after he's done, he cleans off his boots real good. Maybe we should clean off our vehicle's boots. White fringe beetle, again, you're going to have a larva. And they go through all of the different stages, so another complete metamorphosis type critter. So again, like I said, we're not going to go through this whole presentation. I want to just try to get to some of these insects. Blister beetles. Have you guys heard of blister beetles? Let me tell you what, this was a little eye-opening thing. Apparently these suckers, like, if your animals ingest just a little bit of them, they're kind of done for. So this isn't so much one that's forage availability, it's just going to take out your livestock. So that's nasty, 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 and apparently that's how they get their name. Check out the blisters on that guy. Right? And then I thought this was interesting. Basically, what happens if you have blister beetles in your alfalfa, even if the animal's dead, it's still toxic. Not the animal, the blister beetle. Even if the blister beetle is dead and you just have bits and pieces, those bits and pieces are toxic, and the end result, death. Not anything that we are looking forward to. Less than 1 part per million is what it takes to take out your livestock. Okay, so blister beetles are associated with grasshoppers. Again, I'm not going to spend a lot of time on this. I wanted to get to the picture of the cutworms, and here we are. Okay, so cutworms I've seen a lot of. I know that we have them, and I think they're pretty much nationwide. So adults and larvae are active at night. They hide by day. They're not overly exciting color-wise, which means they easily hide and you don't see them. And the larvae often cut plants off at soil level. So you talk about some serious reduction in forage availability. Cutworms sound like something you might want to really monitor and make sure you don't have in your fields. Okay, and so that was the picture of, and we've seen this. It's the alfalfa caterpillar. And here we go. This was the last one I wanted to talk about. The leafhopper. Okay, so they have these piercing, sucking mouth parts, and they suck out the stem sap. So if you have a few leafhoppers, not a big deal. But I know when I walk through our fields, it kind of looks like little fireworks going off as I'm walking through the field because they're just jumping everywhere. So this is something that we have as an issue. So we're going to go back to my PowerPoint now. I'm hoping that that's what you see, though. Actually, we're going to go back to the Google Hangout real quick so I can see what you're seeing. Oh, you're seeing me. Okay, well, let's get back to my presentation over here. We're at the right spot. Okay. Okay, so this link will take you to that presentation. It goes through a little bit more detail about each species and what you can do to get rid of them. All right, I feel like you're not seeing me because my, screen share, Google Hangouts. I had that all worked out, and then I think I have to leave that up for it to go on. The big hit with the Google Hangout is the camera button was still on, and if the camera button's still on, then you're not seeing PowerPoint. Just bear with me a moment. Like the sound effect? Yeah. Crickets. Aha, there. That should do it. Start the screen share. And my camera went out, so we're good. Okay, so best managed practices. Okay, so you're looking at lots of different things. First thing you need to do is assess and see what's even there. Okay, if you don't have any problems, then oh, happy day. But if you do have a problem, what are you going to do about it? Integrated pest management is a combination of appropriate biological, which would be like using, in this case, this is a very unfortunate tomato hornworm who has had a parasitic wasp lay eggs on him, and then these little worms basically eat it alive. It's very sad and yet very effective, especially if you're a tomato farmer. You really don't want tomato or tobacco hornworms chilling on your crop. However, you know, it's just interesting. That would be a case of biological. Chemical, that's going to be your pesticides. Cultural pest control. Now, cultural is funny. It's learning the culture of the insect and then using that information to wield it and use it and conquer it. So, if you're a plant or if you're a pest that doesn't like a wet, moist climate, I'm going to make sure, if I can, if it's possible, to either irrigate the area, or if it's my lawn even, to get the sprinklers going. Chinch bugs are one of those things that does not care for a lot of moisture. If they like tall stands of forage, then maybe we need to get into a better practice of cutting that forage down. But cultural pest control is learning what does that pest like and then making your fields not what it likes. So chemicals are pretty much going to be a last resort, I hope, just because it's an expense, and just, you know, it's like with regular antibiotics. You're not just killing the bad bacteria, but you're killing the good bacteria. And so you might not just be killing the bad bugs, but you're also going to be killing the good bugs. And bugs are essential. I mean, they're part of that primary and that secondary level of consumers, as well as your decomposers. Also, if you minimize soil compaction, that does seem to help a bit. And then really pump out those beneficial insects that are already in the environment, and you're just capitalizing on them. And a lot of those you can actually order and increase as long as you're still within that carrying capacity. Of course, we wouldn't want to overtax our ecosystem. So questions for the future. This presentation gave me almost more questions than it did answers as far as my curiosity. Is there a relationship between the degree of competition insects have with livestock and their metamorphic mechanism? I kind of already referred to that. I'm very interested to see who gives livestock more of a run for their money. Is it the ones who go through incomplete or complete metamorphosis? Then there is, what effect, if any, does rotational grazing have on macroinvertebrate biomass of a given area? And that's actually a question I'm going to research as far as part of my degree. That's going to be kind of my little question that I'm looking into, because I've just been fascinated with that idea for a while. And then the last one, in areas where biomass of invertebrates is low, is there a correlation with that soil quality? We're looking at a lower or high pH, nutrients again. That's sort of that cultural idea that we had on that previous slide, that cultural pest control. What's going on with our soil? If I increase or decrease my pH, could that then really greatly affect my pests and then also my beneficial insects? I have as many works cited. I mean, if I use it, I put it on there, and I put it on there hopefully so that you guys would check it out, because here's this one here is that invasive list. They had, I think, 101 different invasive insects. There is no way to really go through and talk about every single insect that could potentially be a problem for you. Reality of it is, you know, if you have an invasive insect, you're probably going to have a problem because it doesn't have a natural predator set up for it. But it can go horribly wrong. Like, I think about the aphids, for instance, okay? So the aphids were a problem. They brought in ladybugs, but the ladybugs that they brought in have no natural predators. And so what happens around here, sorry, my cameramanship is not very good. What happens around here is every fall our houses are covered with ladybugs because they have gone through and just made themselves a very happy home, and it does not require, or it does require, some sort of intervention because they're unchecked. So, bottom line for me, yes, insects can have an effect on forage availability if they are not in balance in their ecosystem. If they're in balance in their ecosystem and you are grazing appropriately and leaving your 50%, I think that everything should be able to jive together in a pretty homeostatic way. But if you get an invasive species, then you're probably going to need to refer to someone who knows a little bit more about insects. All right, well, I hope this was helpful, and I greatly enjoyed the topic. So anytime you want to talk insects and forage availability, I'd be happy to answer any questions that I can. All right, well, you guys have a great night and or day, depending on when you're viewing this. And I look forward to reading all of your presentations and listening to them. Thanks, and have a good night. Here, maybe. Never mind. Awkward silence. It was supposed to be applause. Instead, it's crickets, which is probably more appropriate because they also eat forage. All right, have a good night.